Hi everyone, this is CS188 Exam Prep Section 5. So the first question concerns Q-learning. So remember that in Q-learning, we maintain a sample of every possible state and every possible action. So in this case, there are states A, B, and C. And for each state, there is a action go and an action stop. And for every action, we maintain the current best estimate of its Q value. So before everything is started, the question says that all the Q values should be initialized to 0. So that's what we're going to do. And then in Q-learning, what we do is we look at each sample that we receive one at a time, and we apply the following formula. So if we look at this formula, what is happening is for every Q value, we're going to update it by keeping some of the old understanding of what that Q value was, and we're going to weight that by 1 minus alpha. And then for the new sample that we receive, we know that it's going to give us a reward. And then after receiving the reward, we're going to continue to act optimally, which is this part of the equation. And then this is the new sample we receive, and we weight that by alpha. So let's try this on the first sample. So the first sample is A, comma, go. The learning rate, alpha, in this case is 0.5. And the old value that we have for A, comma, go, according to our table, is 0. And then with weight alpha, we're going to add the reward we get for A, comma, go, which we establish here is 2. See, alpha is 0.5 here. And then the discount factor in this question is always 1. And once we're in this new state, S prime, which is B, we need to look at the best possible action we can do in B and the best Q value we can get from there. So there's only 2 at this point. At B, comma, go, the best Q value is 0. At B, comma, stop, it's 0. And the max of those 2 is currently 0. So if we evaluate this, we should just get 1 for A, comma, go. Now we just repeat this for the second one, which is C, comma, stop. So at C, comma, stop. Before we should do that, we should also update that the best value for A, comma, go is now 1. And we update this as we take new samples. So in the second sample, again, learning rate is 0.5. The current value of C, comma, stop in the table is 0. Then with the learning rate 0.5, we look at the reward we get here, which is 0. The discount factor is 1. The second action lands us in A, so we look for the best possible action in A. And right now, the possible Q values in A are 1 and 0, and the max of those is 1. So that gives us a value of 0.5 for C, comma, stop. Now we can keep doing this for every sample we take and work all our way down to C, comma, go, which is the next one the question asks for. Or if we're a bit clever, we can go straight to it, and you'll notice that. So first we just write out a little bit of it. So the current value of it is still 0. Now we know that the current value is still 0 because C, comma, go, this is the first time that we've seen it. So even though we've skipped computation of these 2, neither of them are C, comma, go, so the value is still 0. And then C, comma, go, notice that it lands us in A with reward 2. The discount factor is 1. And at this point, now I want the best thing I can do in A, the best Q value possible in A. Oh, sorry, this is a Q. The best Q value the best Q value between S and A, S prime and A prime. So now that I've landed in A, the best thing I can do in A, well, notice that even though we've skipped the computation of these 2, they're only going to affect the values for B, and that the Q values for A are still going to be unchanged because these 2 samples are unrelated to the Q values for A. So that means that the Q values for A are still 1 and 0, and the max of those is still 1. So if we calculate this out, you'll still get 1.5, and that has allowed us to skip computation of these 2. So you might notice that keeping track of an entire table like this first question might be a little unwieldy if your state space is very large. So the second part, they asked us to replace this with something called feature-based representation. So to calculate Q values in a feature-based representation, there are 3 steps you should take. So the first step is to calculate the current Q value at that state. And to do that, you look at the features that correspond to that state. And these are just known depending on what the state is. And you weight each of those by your current understanding of what the weights are, which are W sub I. The second step is to see how far your current estimate of the Q value is off. So first, you take a look at the new value that you receive. So this is going to be the reward. And then what you can do optimally in your new state S prime. And then you subtract that from your current understanding of what the Q value is, and this just comes from the first step. And the final step is to incorporate this difference into your new estimate of the weights by multiplying by alpha, the learning rate, and multiplying it by the current feature at this state. So using these 3 steps, let's try to calculate the weights after this first update of A, go, B. So the first step is to calculate the current Q value at A, go. Remember that all the weights are currently initialized to 0, so maybe we'll keep track of the current weights that are 0. And so first we have W1, which is 0. Now F sub 1 is going to be the feature at this current state. Notice that F sub 1 is just going to be 1 no matter what. So the first feature at this state has value 1. The second weight is 0, and the second feature at this state is currently 1 because A in this state is go. So the current Q value at the state is 0. Next, we calculate the difference. So the difference is the reward for the current state. Well, the reward for the current state is 4 plus. Now we have to figure out the max of the current Q values at this state. So now that you're in state B, technically what you would have to do is use step 1 to calculate the Q value of B, go and B, stop, because those are the 2 actions at this state. But notice that right now both the weights are 0, so you can just say that both of these will sum up to 0. So the best Q value in this new state B is 0. And the old Q value from step 1 is 0. So the difference from equation 2 gives us 4. And now we simply just update the weights. So the first weight used to be 0. The learning rate is 0.5. The difference is 4 from the previous equation here. And F sub 1, in this case, we know that the first feature at this point is 1. So this gives us 2 for the first one. And for the second one, similarly, the old value of the weight was 0. The learning rate is 0.5. The difference from equation 2 is still 4. And the second feature at the state is 1 because the action is go. So we get 2 for the second one. So for this first update, the weights are 2 and 2. For the second part of this question, first we should update our understandings of W1 and W2. And go to this. So again, we followed the 3-step process. The first step is to calculate the Q value at this current state. So the second sample we have is B, stop. Again, we sum over each feature weighted by the current weights. So the current weight for the first element is 2. The current feature for B, stop is 1 because the first feature is always 1. The second weight is also currently 2. And the second feature, well, it's 1 for go and -1 for stop. And this Q value has stop, so it's going to be -1. So the current Q value is 0. The second step is to calculate the difference. So the reward for taking this step is 0. And then after taking this reward, now you're going to be in state A. So we have to calculate the max possible Q value once you're in S prime, which is A. So in this case, because the weights are not 0, you can't just assume that both Q values are 0, and you should probably try to compute the Q values for both Q, A, go, and the Q value of A, stop. So for A, go, it is 2. So for A, go, we have the first weight is 2, the first feature is 1, second feature is 2, and because this is go, the second feature is 1, so this is 4. And for this one, you're going to have the first feature is 2, the first weight is 2, the first feature is 1, and then the second feature is 2, the second weight is 2, and the second feature is -1. So that gives us 0 here. The max between 4 and 0 is 4, so we have a 4 here. And the old Q value coming from the first equation is 0. So the difference is 4. And the third step is to update the weights. So the first weight, it used to be 2. From here, we're going to add a learning rate, which is 0.5. The difference, 4 from the second equation. And the first feature is always 1. So this gives us 4 for the first feature. And for the second feature, it used to be 2, again from here. The learning rate is still 0.5. The difference is 4 from here. And the second feature from here is -1. So that gives us 0 for the second one. So the weights are now 4 and 0.